Good evening, dragons. I am here with you to go over warming the bench, specifically 2.3. If you recall, we did the warm-up together, where we talked about shifting of the place values when you divide or multiply by a power of 10. And multiplying by a fraction where the denominator contains a power of 10 is the same as dividing by a power of 10. We did some note cards together that showed all that movement and the shifting of the place values. You had a good class discussion about interpreting these phrases in famous quotations. Then we went into ordering fractions, decimals, and percents. And you worked with your peers to make a human number line. And I thought you did really well. We hung up that number line on the side of the wall so we could go from least to greatest. And most people decided that it was best to convert everything to percents. Most people found that to be the easiest. We went into analysis in this question here, debating whether Noah and Dylan, who was right, who was wrong, and we discovered that Noah had a huge discrepancy in his accuracy and the fact that he believed 1/10 to be the same as 1/10%, when in fact they are very, very different numbers. We ordered these least to greatest. It was easiest when we all decided to agree on percents. Then we dove into using visual representations of percentages, and we had some answers for the battery icon, and we put those percentages in, and we had some circles. We did some chopping up there. We played with that there. Remember, we struggled together on that one. Now we have this section. Some classes got to this section, some didn't, but it's not that long, so I can go through with you now. So if you wanted to chop this one up, what pieces are you feeling? I feel like I want to do that. So that means I have 2/3. And 2/3 is the same as 6/10 repeating. Or 2/3 is the same as 66 and 2/3%. Here, are we feeling 5s or 6s? I think I'm feeling 5s. Yep, 1/5. 1/5. You could scale that way up. If you don't know how to do that, let me show you now. The reason I want to scale it up is so I can easily convert it to a percent. Once I'm 20 out of 100, that's the same as 20%. Also, once you're 20 hundredths, it's easy to write as a decimal. You could write 2/10 or 20 hundredths. I want to say that it's cut up into fourths. Let's go with that. 3/4. 3/4 is 75 hundredths, which is 75%. I feel like it's fifths again. See if you feel like it's fifths. It's a lot of them. 4/5. Well, if 1/5 is 20% and you have 4 of them, how much percentage do you have? Think about it. This was worth 20%. Now you have 20, 20, 20, and 20. I could scale this up as I did so here, but you can also think of it logically. You have 80%, or 80 hundredths. Here, I'm seeing this as being able to flip or move around. I see this as 1/2. This one I'm cutting, so that's 1, 2, 3, 4, 5, 6, 8 pieces. 3 out of the 8 pieces are shaded. This one we've worked with before in We Are Family, and it's not a friendly number. 3 divided by 8 is 375 thousandths. Multiply it by 100 to turn it into a percent. I'm going to write the decimal first, 375 thousandths. And then multiply it by 100, you're going to get 37.5%. let's look at 2.3, benchmark percents. This is an extremely useful skill. I didn't want to skip over this, even though we didn't have enough time in the day, because benchmark percents can be used when shopping or when banking, and I actually personally use benchmark percents when I go shopping and I want to maybe buy some clothes on sale and I try to figure out what is the sale price really fast. I can do so in my head because I use this concept right here. Let's read together, and I'll teach you how this works. A benchmark percent is a percent that is commonly used, such as 1%, 5%, 10%, 25%, 50%, and 100%. With fractions and decimals, benchmarks can be used to make estimations. With percents, however, you can use benchmarks to calculate any whole percent of a number. So we're going to take a look at these. They are very similar to fraction bars. And we're going to compare and contrast what relationships they have to one another. The character here wants us to remember that you've worked with benchmark fractions such as 0, a half, and 1. And you'll continue to do that throughout middle school. Use the tape diagram to state each relationship. How is 50% related to 100%? 50% is half of 100%. How is 25% related to 100%? 25% is 1/4 of 100%. How is 25% related to 50%? 25% is half of 50%. Let's look at that. See how it takes 2 of these to make 1 of these? That's 50% is half of 100. 25%. It takes, ignore the 50 for a second, 1 of these, 2 of these, 3 of these, 4 of these to make 1 of those, or 2 of these to make 1 of those. How is 10% related to 100%? It takes how many 10% to make 100%? How many here to match this bar? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10% is 1/10 of 100%. How is 10% related to 50%? How many of these does it take to create this? 10% is 1/5 of 50%. Continue the pattern from the tape diagram to state each relationship. We're looking for the patterns. How is 5% related to 10%? 5% would be here. And this would be 5%. What relationship does 5% have to 10%? Good. 5% is half of 10%. How is 1% related to 10%? Well, I don't know if I can fit it, but I'm going to try comparing it to, let's see, I need these tiny little guys that are not drawn to scale. Each one of those are representing 1%. All these little guys I'm saying are 1%. What relationship does one of these have to this? One of these is worth 1/5 of this. Or one of these is worth 1/10 of the big thing, the 10%. Let's look at the question. How is 1% related to 10%? 1% is 1/10 of 10%. 1% is 1/5 of 5%. Now they want us to use benchmark percents to determine each value if 600 is worth 100%. I could show it with the diagram here, but I actually can show you something else that looks kind of like a double number line, which you're also familiar with. So if I am here at 600 and I am saying 600 is 100%, they want to know what 50% is. If I cut 100% in half, I also want to cut this in half. So this is a divide by 2, therefore divide by 2. What's your answer? Good, 300. What if I wanted 25%? Let me go in with another color. I want 25%. How do you get from here to here? You can cut it in half again. So what's 300 cut in half? Good, 150. 10% I actually don't use a double number line in my head. I use place value. If 100% is 600, 10% is going to be one place value less than that, and 1% is going to be one place value less than that. Or you could take 600 and divide it into 10 parts, knowing that each part is worth 60. Either way, 10% is 60. 5% is half of 10%. 5% is half of 10%. So what are you going to put? 30. 1% I already showed you with the place value. 6. Use your calculator to determine the percent of each number. And I truly do want you to use your calculator. 1% of 28. Now, if you don't know, there was a little note on this side. You may have caught it, you may not have caught it. 1% is 100th. So if you want to use your calculator for this, you would type in 100th times 28. If you want to do 10% of 28, 10% is 10 over 100, and 10 over 100 is 1/10. Be careful, they are different. And this would be 1/10 times 28. Two and 8/10. Okay, 1% of 28 was 28 hundredths. 10% of 28 is 2 and 8/10. I want you to pause the video and try these problems where you're going to do 1/100th times 234. You're going to do 1/10 times 234. And you're going to go down the line and do all of these. So take a moment, use your calculator, calculate all of these. When you're ready, resume the video. What patterns And I'm hoping you see place value. What patterns do you notice in your answers in question 4? 1% of a number shifts the place values what? Which way? Shifts the place values two times to the which way? Let's take a look at it. Let's take a look at one. 1%. We were at 28. And I shifted once to be 10%. Shifted twice to be 1%. I shifted the place values 2 times to the right. This, sometimes people say I moved the decimal 2 place values to the left. %, shift the place value 1 time to the right. I'm overflowing here. Or moves the decimal 1 time to the left. Moves the decimal 1 time to the left. Okay, so that was all number 5. I ran out of room. Write a rule to calculate 1% of any number. Move the decimal 2 times to the left. Write a rule for 10%. Move the decimal 1 time to the left. Use the patterns to calculate each value. 10%, we're going to move it once. 1%, we're going to scoot it twice. 10%, move it once. 1%, move it twice. 10%, move it once. 1%, move it twice. Check to see if that's working for you. I got 2 decimals in that number. Did you see that? That's it. We're going to save the rest for tomorrow, which is some word problems on the same concept. Basically, 1% and 10%, you're just moving place values. Easy peasy, lemon squeezy. The other ones, you have to think a little harder. But I will teach you a bunch of tricks on how to do this in an efficient way and using mental math. Thank you for joining me this evening. I hope this was worth your 20 minutes of leisure time. Bring your questions about percents to class tomorrow. Thanks.